Hi guys, welcome back to In Case of Econ Struggles. Today I'm going to talk about production side externalities. Specifically, I want to get into an actual problem using a production externality, and I want to talk through how to solve the math. What I really want you guys to understand is both how to solve it mathematically and intuitively what's happening with the problem regarding externalities, so you guys feel more confident solving those problems going forward. Now, like I said, I'm going to focus on production externalities today. In a separate video, I'll cover a similar sort of thing with consumption externalities. So if you want to be notified when I post that video, make sure to subscribe if you haven't already, and make sure to click the bell. So let's go ahead and get right into it. Just as a basic review before we jump into that problem, let's really quickly review externalities. And with externalities, remember we can sort of think of this in a supply-demand diagram sort of way, where the supply curve comes from private marginal cost and the demand curve comes from private marginal benefit. And this is sort of a shift from how we see the supply and demand curve. If it's not familiar, if you don't remember when we covered that in that past video, I'm going to put the link in the description below, and I'll make sure it pops up in the right hand corner right about now. And so what we said with externalities is that when we make supply equal to demand, when we're equating private costs, we're going to get what we call the competitive equilibrium. If there were no externalities, that would be Pareto optimal. But now that we have these externalities, we don't have the first fundamental theorem of welfare economics, which means the competitive equilibrium is not social optimum. And we need to really think about, well, what is the Pareto efficient outcome here with these externalities? Now, these externalities can come on the production side or the consumption side. They can be positive or negative. So what I've done on this screen here is just showing you an example of a positive and a negative externality, where this polluting steel plant is a negative externality on the production side. That's actually what we're going to talk about in the problem today, where what's happening is you got a steel plant on a river, they're producing steel. The steel plant is only thinking about how much it costs their own steel plant to produce that steel, but in making that steel, they're going to release some pollution into the river. It's going to affect a fisherman downstream. That's an external cost of producing steel, and so when we think about the socially optimum amount of steel to produce, we need to think not only about those private costs, but those external costs as well. On the other hand, you could have a positive production externality, such as if you're producing honey or a beekeeper, maybe keeping those bees is benefiting another farmer because those bees are pollinating other plants, and maybe other farmers are using those plants to make their living. And like I said, you could also have this on the consumption side, where in a separate video, we're going to talk about this smoking example and thinking about, well, what is the optimal number of cigarettes to smoke socially versus in a competitive equilibrium. So if we think about all the different possibilities, if we think about four major possible externalities, positive or negative production, positive or negative consumption, we can make four different graphs. We're on this top row. These are going to be negative externalities right here. And these are going to be negative externalities because what you can see is that where the marginal social cost equals the marginal social benefit is to the left of the competitive equilibrium. Here we've got a negative production externality. Here we've got a negative consumption externality. These bottom two graphs represent positive externalities, both on the production side and the consumption side. And so if these graphs don't make a ton of sense, make sure to really check out that other video on externalities that I posted. And again, feel free to comment any questions that you have. And so now we're basically ready to get into that problem that I mentioned earlier, where we have two major questions that we're trying to ask, which is what is the competitive equilibrium? What is the competitive equilibrium amount of output, amount of production, versus what is the Pareto efficient point? And then sort of a third question is how can we use some sort of market mechanism to basically guide the market from the competitive equilibrium to the Pareto efficient level of output? How can we basically internalize this externality or make the individual parties feel this externality and take that into account when they're choosing how much steel to produce? So now we're going to get into the problem. And like I said, this is about a steel plant producing steel, affecting a fisherman downstream. And just to make it a little more complicated, I'm going to make it be two steel plants versus one fisherman. Okay, so we've got two steel plants. We've got Eva's steel up here and Dana's steel down here. They're each going to take one input. So maybe this is one steel ingot or something, and they're going to produce 1 ton of steel, which is going to be 1 SE. This is Eva's steel versus Dana's steel. And now every time they produce 1 ton of steel, they're going to produce 1 ton of pollution. This is going to be XE for Eva's pollution and XD for Dana's pollution. Now that river is going to take that pollution downstream, and that's going to affect Fisher Bill, where Bill is just trying to produce an amount of fish F. and he's just doing that by sitting on the dock and fishing from this river. For some additional context and for the math, we're just going to say that the price of steel is equal to the price of fish, which is just $1. Maybe this is per ton of steel / ton of fish. I don't know. Maybe the units will make more sense if it's one steel beam and one fish. I don't know. We're just going to make the prices equal to each other. On the cost side, we're going to have this sort of complicated function for EVA, which is going to be a piecewise function, where again, SE is going to be the amount of steel, XE is the amount of pollution. And basically what we're saying is that for EVA, if she produces enough steel, this pollution doesn't affect her cost. And same thing for Dana, where this pollution sort of drops out if she produces at least 4 units of steel. And Bill's cost, notice Bill's cost here is F squared over 24, plus the amount of pollution that EVA puts in the river, plus the amount of pollution that Dana puts into the river. So here we can see that EVA and Dana, their costs only involve themselves, but Bill's cost includes both EVA and Dana's pollution, which means that EVA and Dana are basically affecting Bill downstream, even though EVA and Dana are not going to think about that when they decide how much steel to produce. If they did think about the fact that their pollution was going to negatively affect Bill, you would expect that they would produce less steel. So that's sort of the intuition here. And now we're going to go about and try to show that. So first, let's just start off by trying to think about, okay, what is the profit maximizing amount of steel for EVA and Dana if they're not thinking about Bill, if they're just thinking about themselves? So what we're going to do is we're just going to set up a basic profit maximization problem where we're going to choose SE is equal to XE, because remember that 1 unit of steel automatically results in 1 unit of pollution. The price of steel is 1. This is price times quantity is revenue. This cost, we have a piecewise function, so we don't necessarily know what that's going to be, but we're going to maximize this profit based on this cost function. And we're going to use the fact that marginal private benefit equals marginal private cost. And I know that marginal private benefit is 1. Marginal private cost is going to depend on which part of that piecewise function we're on, so we sort of have to guess and check. So maybe I'll first guess that we're under case 1, where we're going to produce at least 1 unit of steel or more than 1 unit of steel, which means that our cost is SE squared, which means that our marginal private cost will be 2 SE, which gives us that the amount of steel we're going to produce is only 1/2. But this is incorrect because our assumption was that we were producing more than 1 unit of steel, so the fact that we get a half here means that we're using the wrong cost function. So instead we need to go to case 2, where our cost function is SE squared over XE to the 1/2. But I know that SE is equal to XE, so I'm just going to make that SE to the 1/2, which means that my cost function is SE to the 3/2, which means that my marginal cost is 3/2 SE to the 1/2, which means that my amount of steel that EVA is going to make at her profit maximization is a 4/9 unit of steel, which is going to be exactly how much pollution she puts into the river, because again, SE is equal to XE. Now we're going to do exactly the same thing for Dana, where again, marginal private cost equals marginal private benefit, where this is just marginal revenue, price is 1, this is the amount that she produces, the cost again is a piecewise function, so we got to guess and check. So again, I'll start with case 1, where we assume that Dana produces at least 4 units. I'm going to go through the math, and I'm going to find that she's going to get 4/3 to the 1/2, which is going to be less than 4, which means again, I'm using the wrong cost function. So I'll go ahead and put in that other cost function, which was SD times XD to the -1. But again, the amount of steel production is equal to the amount of pollution. So I can just rewrite that using SDs, and I'm going to get SD squared, which means that the marginal private cost or marginal cost here is 2 SD, which is 1/2. Now for Bill, we can think about how much Bill wants to make in a profit maximization sense. This is sort of important to remember. And what's important to remember is that when we think about Bill's cost function, Bill can only choose the amount of fish that he's taken out of the river. Bill has no ability to go over and tell Eva or to tell Dana, hey, this is how much pollution I want you to put in my river. That's a completely exogenous decision to Bill. That is outside of Bill's ability to control, which means that we're just going to take these as given. So what's going to happen is we're going to say that Bill's profit maximizing amount of fish is always 12, no matter how much pollution Eva and Dana put into the river. So Eva and Dana are going to affect Bill's profit. They're not going to affect how many fish Bill wants to pull out of this river, according to his profit maximization problem. So now if we put everything we sort of found together, well, we found that Eva is going to put out 4/9 amount of pollution. Bill's amount of fish is going to be 12. And so now what we can do is we can plug these values back into profit functions and figure out what is everyone's profit right now. Well, if I use Eva's profit, I'm going to get 4/9 minus 4/9 to the 3/2, where this 4/9 to the 3/2 is going to be bigger than 4/9 to the 1. So this is going to be some negative number. Dana, on the other hand, she's getting 1/2 minus 1/2 squared, which is a fourth. And Bill is basically going to get this 12 minus his cost function minus Eva's pollution minus Dana's pollution, which is going to be something about 5. I didn't really do the math. I'm just sort of rounding. It's going to be about 5. And so the total amount of profit right now is slightly less than about 5.25, which means that if we were to go to the social optimum, it's going to be a Pareto improvement if everyone's profit, if total profit increases, if it goes up from slightly less than 5.25. So now what we're ready to do is we're ready to go back through and find where marginal social cost equals marginal social benefit. So if I think about Bill's cost, again, what's happening is that Eva's external cost and Dana's external cost is 1. Because every time that Eva and Dana increase their steel production by 1, they increase Bill's cost by 1. So this marginal external cost is 1. And so what I can do is I can take these private costs, these marginal private costs, or these total private costs here, and what I'm going to do is I'm just going to add 1. Because now I'm going to add the fact that if I take this derivative, I'm going to have this marginal external cost here of 1 because of the fact that Eva and Dana are now we're going to sort of think about, well, if they internalize that cost, they would realize that their total cost is not just their private cost, it's also their external cost as well, and so that's what I'm doing here. So now we can go back to Eva and say, okay, well, let's do a new profit maximization for Eva, where we have this external cost in here. And if we do that, what we're going to find is that her profit maximizing, or her social profit maximization, is going to lead her to the fact that the amount of steel that she should produce is 0. She shouldn't produce any steel at all. Similarly for Deb, if we add in that marginal private cost and the marginal external cost to get a marginal social cost of 2 times the amount of steel she produces plus 1, we're also going to get that the Pareto optimal amount of steel that Dana should produce is going to be 0. So what we've gotten so far is that Eva and Deb should both shut down their steel plant based on accounting for their marginal external cost. Now for Bill, we knew that his problem doesn't change because he doesn't get to choose Eva and Dave's pollution level, so he's still going to make 12 fish. And now if we go back to these profit functions, what you're going to see is that before we said that we got a profit of less than 5.25, and now what's happening is Eva has a 0 profit because she's not making anything. Dana has a 0 profit because she's not making anything. Bill is still fishing 12 fish and his profit is 6. And so our profit has now increased from less than 5.25 to 6, which means that the social welfare is increased. And so this is a Pareto improvement. And in fact, this is the Pareto optimal outcome given this externality. And so what we're saying is that Eva and Dana should both shut down because the marginal benefit of producing steel is this price of steel, which is 1 for both people. But the marginal external cost of producing that steel is also 1. So what we're saying is that already this marginal benefit is equal to the marginal external cost. So if there's any marginal private cost, which we know there is to produce this steel, then it's not worth it socially to produce any steel at all, because for any steel you produce, you have a negative social profit, basically. And there's multiple ways to show this, and I'm going to show this in sort of 2 different ways. The first way I'm going to show this is to think about a Pigouvian tax we would put on the steel if we wanted Eva and Dana to internalize this externality. So what we would do is we would impose a Pigouvian tax of $1 per ton of steel, because that is equal to the marginal external cost of producing steel. That's how much it affects Bill's cost function by, which again just means that the effective price of steel is 0, because if you put in this Pigouvian tax and the price is 1, 1 minus 1 is 0. So if the price is 0, it doesn't really make sense to produce any steel if it costs you any money to make that steel. Again, we know Eva and Dana both have private costs, so their profit maximization with this Pigouvian tax would be not to produce any steel at all. Another way you could sort of explain this is to do some joint profit maximization, where you say suppose that one person controlled both steel plants and the fishery, And this person could choose how much steel Eva and Dave produce and how much fish Bill produces. They're choosing all of these together. And so you could have a joint profit function where basically you're going to maximize profit, where this is Bill's profit, this is Eva's profit, and this is Dana's profit. And again, I'm using the fact that the amount of pollution is equal to the amount of steel for both Dana and Eve's plant. And then you could take 3 first order conditions, where each first order condition is basically going to be each person's profit maximization problem with this external cost. Because what's happening is we are choosing SE and SD, so we're thinking about the fact that those SE and SDs come up in Bill's profit maximization problem. And so what I've sort of done here is sort of color code it, where you can see that this is a marginal external cost, this is marginal private benefit for each person, Bill, Eva, and Dana. This is private cost for Bill, Eva, and Dana. And when we do this, we're going to see that, again, Bill's optimal amount or Pareto optimal amount of fish is 12. For Eva, we're going to get to the step that 3 halves SE to the 1 half is equal to 0. And so we're going to produce 0 steel. And for Dana, it's going to be the same situation where we're setting to SD equal to 0. And so the Pareto optimal amount of steel that Dana should produce is also 0, which we're getting the same answer as before. So again, all we've shown is how can we, with math, figure out what the Pareto optimal amount of production is given this production externality, and how can we sort of think about it intuitively to say, is my math correct, does my math make sense or not? And here I think the thing that really makes it make sense is that if the price is 1 and the marginal external cost is 1, then basically that effective price became 0. The effective price is 0, you probably don't want to make any steel because it's really just not worth it. You're not going to get any revenue from making that steel. And so it's better, it's a Pareto improvement just to shut down those steel plants. So if you've got questions, I know this is sort of complicated, please feel free to throw that in the comment section below. But if this video or these videos in general helping you out, please like and subscribe. See you next time for another case of Econ struggles.